So in the second attempt at the exercise, I'm working from exactly the same list of tests, but this time I'm deriving my design directly from the outside. So you'll notice that they're the same test cases, but this time I'm only using this external exec method and passing in an instruction like R for right and L for left. So exact same test, but we're driving it this time directly from the outside. In terms of the implementation, at the moment, what I've got is a single exec method, and everything that happens at the moment is inside this one big method. So what I'm going to demonstrate now is how by refactoring this method into its individual chunks, we can extract those pieces of the jigsaw that we kind of saw before or very similar, but this time they're being discovered through refactoring rather than planned by deliberately test driving them up front and then putting the jigsaw together. And one of the advantages of doing it this way is we can guarantee that the pieces we end up with will fit together. One of the dangers of doing inside out TDD is that you test drive all of the individual pieces of the jigsaw, and then when you try to put the whole jigsaw together, they don't fit. This time, because we've got something working, we can guarantee pretty much if we refactor this into individual pieces that all the pieces will fit. Okay, so let's start by just stripping out some of these constants so we can declutter our function here. Okay, there's one. Let's go do the other. There's the other. Okay, and we immediately, of course, rerun our tests. Excellent. Now let's look at each of these individual behaviors here inside our reduce. Turning right, so let's extract that into its own function. So there's a function for turning right, and immediately I rerun the tests. Turning left, well, okay, let's extract all of that. So now we have our right and left functions. More work to do. Now let's look at going forward and backwards. So let's extract a method for going forwards. Okay. And we can now extract a method for going, a function, sorry, for going backwards. Okay. Right, so we have our full functions as we did in the previous example, but this time what we've done is we've refactored to introduce these functions, so they're guaranteed as pieces of the jigsaw to fit inside the jigsaw. Okay, what else can we do to simplify it? Well, whenever I see a list of if statements that say if instruction is R, then do this, if instruction is L, then execute this function, if instruction is F, then I see a dictionary. Okay, so let's refactor this by introducing a dictionary. Okay, let's call them commands. And we've got a command for going right. And we're going to map that onto the right function. And we've got a command for going left, and we're going to map that onto the left function, and so forth. So F for forward. And oops, comma. And B for back. Okay, so now we have a dictionary that we can use to look up. I've done a bit of typing there, so I better just check that I haven't broken anything. Okay, nothing's broken. And now what we can do is we can get rid of all these instructions by just using the appropriate command. So whatever our instruction is, we will invoke that with our rover there. Okay, hopefully that's all commands, sorry. There we go, that's better. Okay, and we immediately rerun our tests. So far, so good, all still working. Again, we can probably clean up a little in here by stripping that out. So let's add that to our little data division at the top here for any old COBOL programmers out there. And so our functions are getting much more smaller, hopefully more readable now. We don't need this whole function here. We can actually just have an assignment like that to our so it is rather starting to look like the original design that I did from the inside. Is very, very similar. There's some little bits of duplication here that I think probably are worth cleaning up. So the duplication is where we move our rover. So let's move our rover. And we tell it which vector we want it to move in. Okay, so we can inline that. And similar kind of thing here. We can actually reuse the move here. So we can, we can just reuse our move function, but with different vectors for going backwards. So that line of code is no longer needed. And immediately rerun our tests. Lovely, that's working. And similarly for turning, these are both examples going right and left of turning. So I think this time we're going to do this one. You'll see why in a minute, because it'll, oh, let's inline that. So that's turning in the reverse compass direction. And here we can reuse that and just turn it in the compass direction, the normal compass direction. Oh, what happened there? Well, that's because you see, this is why we pair program. That in actual fact is the turn function. This is the right function. That's the one I want to reuse. Little mistake there. Hope you were paying attention. And now let's run our tests. And they're all passing again. Okay, let me just clean up a little here because right, left, turn the move makes a little more sense. And that's how I made that mistake in the first place. Okay, so right, left, turn, move, forward, back, execute here. So we've come up with a very, very similar design here. We've done it working from the outside in. So we wrote tests from the point of view of the external interface, if you like. And we wrote an implementation that passes those tests, and then we refactored that implementation and discovered an internal design. We've got lots of nice small functions, very little duplicate code, and all the other lovely things that we like to see in proper functional programming code. The advantage of this approach, first and foremost, is that we are driving that internal design, the pieces of the jigsaw, directly from the whole jigsaw. So if we were talking about designing a jigsaw, what we've done here is we've taken a picture on a piece of card and we've cut it into pieces and made a jigsaw. When we do it inside out, what we're doing is we're actually creating individual pieces of a jigsaw and then hoping that they will all fit together at the end. And that, of course, is less likely, particularly as the design gets more complex. But there are other big advantages of working from the outside in, and hopefully you can see that if you look at my module exports at the bottom there, I'm only exporting one function, whereas with the previous example, I exported almost the entire internal design, all the pieces of the jigsaw for my tests. Now I'm only exposing one part of the jigsaw, the exec function. And if we look at our tests, They only depend on that. So they're far less tightly bound to the internal design of what they're testing. And what that means going forward is it will be much easier to refactor and change the internal design as we see fit without having to rewrite lots and lots of test code. So two big advantages there. One, you're far more likely to end up with pieces of the jigsaw that actually fit together. In fact, it's pretty much guaranteed if you work from the outside in, if you start with the external picture. And the other advantage is you end up with test code that is nicely decoupled from the things that are being tested. But there is a disadvantage as well to working in this way from the outside in, which is when any of these tests fail, because we're going through that keyhole, if you like, through the exec function, there's a danger that our tests won't pinpoint exactly where the problem is. There's a call stack we have to dig into. So when I work from the outside in, the risk is that I end up spending more time in my debugger trying to figure out, well, yeah, the test is failing, but where's the error? The analogy I use is, if imagine you've got a gas leak in your house. So they come and they measure the gas pressure at the meter outside your house and go, somewhere in your house there is a gas leak. Now, if that's the only place you can test for leaks, outside the house, out the gas meter, that means there's a danger that in order to figure out where the leak is inside your house, you might have to start ripping up floorboards and pulling out walls and plaster and stuff to get to the pipes to figure out exactly where the leak is. At the very least, we'd like to know which room the leak is in. So there is a compromise to make here. There's a balance to be struck in terms of where we write our tests. Do we write them all at this sort of external API level? But what we tend to find is that's not such a great idea unless the software itself is very, very simple. So that might work, for example, for microservices. But for code bases, for components that are bigger than that, we tend to find that we do need tests that are talking directly to internal interfaces. Let's call them internal APIs. So there's a balance to be struck here. We don't want tests that know about the whole internal design, but we do want tests that maybe in larger components know something about the internal design. They can pinpoint a part of the software, a package, for example. So how do we achieve this balance? How do we get it so that we are guaranteeing that the pieces of the jigsaw fit together, and so that our tests are nicely decoupled from the majority of the internal details? We have good encapsulation in our modules, but at the same time that pinpoint to a certain degree of accuracy, pinpoint where things are going wrong. And what we'll be doing in the next video is demonstrating an outside-in design technique that uses mock objects and stubs, what we call test doubles, to allow us to drive a design from the outside in, but that also allow us to write our tests at internal layers within the design, at key points within the design, to help us write tests that pinpoint errors more accurately. Okay, so I'll see you in the next video.